The IUPAC name is just what we would always use as the names for organic compounds. So here you had to look at the molecule, you've got 2 carbons, so it must be an eth something. It's got an OH on it, and it sort of tells you that that means it ends in ol. So you just had to realise that the double bond in the middle gives it an ene in the middle instead of an ane. So the 2 carbons means it's eth, which could be either A or B. The ene in the middle is because of the double bond, therefore the answer is B. Bromine water, we know, reacts with alkenes and goes from orange to colourless. Okay, which is worth a mark. And then just because of the carbon-carbon double bond. Okay, was the second bit to say. When you're doing polymers, for addition polymers, the format is always the same. Okay, you're always going to start with some sort of alkene. If every time you draw your alkene in the same way, the double bond has always got effectively 4 things coming off it. Okay, now if those 4 things were all hydrogens, and you'll probably be more familiar with this example, okay, then the repeat unit of the polymer, those hydrogens would effectively just stay joined to the carbons. The double bond here breaks, okay, so that bit, let's just sort of show this, that bit breaks, and we get 2 new bonds being formed, going to neighbouring molecules sticking out the side. You could put a bracket around that, but it only said draw 1 repeat, so if you had n of these, you'd end up with n of those joined in a big long chain. Now PVA is different, so that example was just kind of illustrative, so we can just kind of get rid of that. It's not really helping us in any way, so I'll just pop that up there. And then what we want to do is look at our monomer, okay, which in actual fact, if we draw it in the same sort of configuration as the one on there, you've got H, 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 and OH. Then just following the same pattern, you end up with the OH sticking off one of the carbons. The other 3 spaces on the carbons are filled with hydrogens, and then you've got your bond sticking out each end. If you had n of those, you'd end up with a big long chain with n of those. A difficult question here. The whole big long molecule of PVA is telling you it's got a relative mass of 27,500. So that means that all of this, okay, thing here, let's just use a different colour, all of this, i.e. n times, has got a formula mass of 27,500. You just have to work out what n is. In order to work out what n is, you need to know the formula mass of just a little bit in the middle. Okay, so in that purple box, what does that bit weigh? Well, you've got 2 carbons, 4 hydrogens, and an oxygen. So if you just add that up, you end up with 44. So n becomes 27,500 divided by 44, which is 625. For the last bit here, you need to understand that an impure substance has a lower and a wider melting point than a pure substance. That will be true for any material. So the one that you might be familiar with is the ice. If you mix it with salt, that lowers the melting point, which is why we put ice on roads on a cold day, because it makes it melt more easily at the temperature of the air. So all you really have to say is either that it was lower or that it melted over a range of temperatures.